All right, this is the Algebra 1, Unit 5, Lesson 5 video over transformations of linear functions. So the concept here is that when we're dealing with functions, and this applies to any type of function, it could be a linear function, quadratic functions, which we haven't covered yet, even functions that are more advanced like square root or x to the third functions or anything, exponential functions. The way that we alter the functions based on like the sort of mathematical adjustments we can make in the equation, they kind of stay constant. And so we're going to look at, first of all, just some big concepts in math that will be really helpful for you to understand going forward. The first is that we have this idea of families of functions or parent functions. So every type of function has sort of like its most basic version of itself. And so with linear functions, that is going to be the function, and I should have done that. Sorry about that. Let's open this in a new tab. There we go. For linear functions, we have the function y equals, let's get this down, y equals x. So this is the most basic function of the parent function y for linear functions. So instead of y equals mx plus b, it's f of x equals x, or y equals x. The graph crosses through the point 0, 0, and there's no sort of changes being made. The slope is a slope of 1, and the y-intercept is 0. So we have no alterations. It's kind of its most basic version. That's what we're referring to when we're referring to parent functions. So from there, we're going to make some alterations. We're going to add things, multiply things, subtract things, and we're going to see what happens when we do that. So the first type of transformation we're going to make is what we call translation, which is going to be a shift up, down, left, or right. So we're going to go through each of these over here. I'll leave the red, which is the parent function, and then we'll go through each type of change, and we'll kind of document that as we go. So let's go over here, and let's start a new note if I can. Okay, weird. I don't know why I'm not able to go. Let's get rid of that guy. Sorry about that. All right. So let's go ahead and get a heading here. We'll call this transformations. The first type is going to be to take we have what we call the parent function, right? So for linear functions, the parent function is f of x equals x. So, but in general, the question becomes, what happens when I maybe add or subtract something to this function? So let's look at two different types. The first is going to be what happens when I do add just a number off to the end. Or on the other hand, what about subtracting a number off to the end? So what would the result be of either of these? So this is going to be a vertical shift. Okay, so adding a number onto the end of the function is going to result in a vertical translation. And so let's look at what that looks like. So in other words, if I do y equals x minus 3, this graph has been shifted down 3 units. So if we go back to our original point and we go down 1, 2, 3 units, this has been shifted down 3 units. So we know that when we do a plus or a minus, this changes the function by making it be, this is going to be a shift up 4, and this is going to be a shift down 3. So what we learned is that when we add a number to the end of our function, we are going to shift it up, and when we subtract, we're going to shift it down. So I'm going to go down here to our summary page so you can see what this looks like on our sort of list of rules. That would be these first two items right here. Function notation, vertical up k or down k units is when you add something to the end. Okay, so what about adding a number just to the x? Well, let's just draw a line here, and let's say, well, what about when we do the following? What about when I do x plus a number inside here, or f of a number minus inside there? So now we're adding or subtracting to the x value of the function. So when we do this, this results in a shift 5 units to the left. And this results in a shift of 2 units to the right. So looking over here, we can see it's not much different from our previous example, but if I add 5, I see that the graph has been shifted 1, 2, 3, 4, 5 units to the left. And if I subtract 2, it's been shifted 1, 2 to the right. So that's where that comes from. And in our summary table, that's the third and fourth lines, plus h minus k minus h. That's going to be left for a plus and right for a minus. And then over here, it shows you how to change the actual individual points. Then we have two ways that we could apply a negative number. So that would be one of two. That would be either doing the following. That would be like doing negative f of x versus f of negative x. And one of them we're making the entire function negative, and then the other we're making just the x negative. So this is a reflection on the x-axis, or that's the horizontal axis, so it reflects along the x-axis. And this would be a reflection on the y-axis. We could do a quick example here. If I do negative x, it looks like that. If I do negative y, it also looks like that. So it actually ends up being the same because we know that reflecting along this axis right here means that this arm comes down here and this arm goes up there. So that would be reflecting there. But the same thing occurs when I do it to the entire function, which is that it reflects the same way. All right. So looking on our kind of notes page, we see, or on our table here, we see negative f of x is a reflection over the x-axis, and f of negative x is a reflection over the y-axis. And you can see over here again the ways in which it changes the values. So then the last type of change we can make is to multiply a number by either the function or by the x. So that's going to look like this. That's going to be if I had some multiplier times f of x. So that would be like 3f of x would be an example of that, right? And so this is going to be what we call a dilation. It's going to be a stretch or a compression, okay? So this would be a vertical stretch or a vertical compression. How do I know which is which? Well, a stretch is going to be, let's actually do this a little bit differently. Let me move this over here. Let me erase this, actually. So a stretch is going to be whenever A is the absolute value of A is greater than 1. That would be like the example I had up earlier, which would be like 3 times f of x. That's going to be a stretch. A compression is going to be when the absolute value of A is between 0 and 1. Okay? That's going to be a compression. So that would be if I had like 1/2 f of x. So this is going to be a vertical stretch up here, and this is going to be a vertical compression down here based on where that number is. Lastly, we have a multiplier that appears in the x part. So that would be like this, f of ax. So notice we're multiplying inside here now. If that happens, we're going to have a horizontal stretch or compression. It's going to have a similar relationship. So a stretch is going to be when A, the absolute value of A is greater than 1, and a compression is going to be when the absolute value of A is between 0 and 1. And I've got those switched. It's pretty typical. So a stretch is going to be when A is between 0 and 1, and a compression is going to be when A is greater than 1. So again, this would be, for example, f of 0.25x versus f of 5x. So those would be examples of those two. All of that information is on this table. And so what you're going to be doing is you're going to be looking at an equation, and you're going to be determining what the correct changes that would be occurring to that function. So I'm going to grab this. I'm going to copy and paste this over here. All right, so we have this in front of us when we're working. And let's jump over and look at some of the example questions. So it says, if the parent function of f of x equals x is transformed into the following: negative 1/2 f times x plus 1. Which graph matches the function? So let's determine which two things have occurred. So first things first, we notice there's a 1/2 in the front, a negative, a 1/2, and a 1 added. So the negative tells me, going back to my chart, the negative tells me that I have a reflection. So we need a reflection. The 1/2 tells me we need a vertical compression. It's going to be compressed, it's going to be reflected, and it's going to be shifted. Plus 1 in the inside is going to be to the left h units, so to the left. So we know that we're going to have a compression, a reflection, and to the left 1 unit. So we know it's not going to go the same direction. So it can't be B. It's going to go in a different direction. It's going to be shifted 1 unit to the left. I see this one is 1 to the left. This one is 1 to the left. This one is not. So it's not A, it's not B. And it's going to be compressed, which means it's not going to go the same. It's not going to go any steeper than the original. This is too steep. So this is more of a shallow line, and so it would have to be answer choice C. And they're going to walk us through that over here to see how that goes. And they kind of explain through how that goes. So then they say some other examples. Look over those other two examples, and let's jump down. So first things first, you have vocabulary for 1 through 6. And then here, describe the change. Okay, well, we notice there are two main changes. We have a 2 inside with the x and a 2 added on the end. So let's look at this 2 out here. So what does that tell us? That tells us that there has been a shift up 2 units. That is the first item on this list right here. We've been shifted up 2 units. So that is a vertical translation. So let's go check our answer choices. We need a vertical shift. Okay, translation up by 2, up by 2, down by 2, up by 2. So it cannot be this answer choice. It cannot be that one. So we get rid of that answer choice C. All right, so let's mark that one off. All right, now what about this other 2? The 2 is inside with the x. So we go over here, and we see that when the 2 is with the x, if it is greater than 1, it's a compression. So we have a compression, and we have a compression by 2. And what kind of compression is it? It's a horizontal compression. So we have vertical, nope, vertical, nope, horizontal stretch or shrink, horizontal compression by a factor of 2. So we know that answer choice D is the correct answer. All right, so that's how you're going to do these. You just need to use process of elimination to go through and answer those that way. All right, more of the same here. What does a negative and a plus 2 on the inside mean? What does a 3 on the outside and a minus 1 on the inside? You need to go back to this list and match each one up. And then again here, which of these represents the type of change that was occurred here? Okay, notice some of these have just one change, others have 2 changes. So which one of those is it going to be? So the original function is the f. The f is the original function, and the g is the new function. All right, and that is it for lesson 5.